Okay, so we're going to do translating sinusoidal functions. A sinusoidal function, we're going to specifically do one called sine here. A sinusoidal function is just something that has like a reoccurring pattern, like sound waves or light waves and stuff like that. Pattern, and it could be like, you know, do a couple weird things and reoccur. I don't know if that's a very good example, but that's the idea behind it, right? So we're going to focus on sine x. And actually, instead of me drawing out, because I'm not wonderful at drawing, what I'm going to do is we're going to bring up Desmos, and we're just going to type it in, actually, to this graphing calculator. Here it is. Now, the one thing about Desmos is it's currently in radians, which you may not be used to seeing. So, like, for instance, this value here is pi over 2,1. We're not used to talking in those things, so I'm going to quickly change this to something called degrees, and I'm going to change our values a little quickly here. We'll go from negative, let's say negative 90. Degrees are large. We'll go to 450. There we go. That looks a little better. Now we can zoom in and out. So if we take a look at this, here's a key point, 0, 0. Another key point, 91. Another key point, 180, 0. 270, negative 1, and 360, 0. And these 5 points are very, very important if we're talking about sine x. And again, remember, we put sine x over here on the left. Those points are important to almost memorize because they give you inflection or points where the directions are changing. So they're great for it. There's a lot of, in fact, there's an infinite number of points in between here. We just don't memorize them because it's too many things. So these 5 are very, very important for what we're going to do. Whoops. So, we've seen the function. I'm going to quickly make a small table here. And we're going to just put our key points. We said 0, 0 was 1. We said 90, 1 was 1. 180, 0. 270, negative 1. And 360, 0. Okay? And essentially, when the pattern repeats, that's considered an entire period. So at 360, our pattern repeats, and we would just kind of continue from there. Okay? Now we have to translate them, which can be hard at first to see the overall how to translate something. So let's go back here. I'll show you what we're actually going to write here. So we could technically have, we're going to say 2 sine x, and then I'm going to put a couple other things in here. We're going to say, what value did you have? You know what, doesn't matter. We'll make our own. Excuse me. Let's say plus 5, but I'm also going to put some brackets in here. There we go. And actually, no, the bracket's in the wrong spot. It's kind of hard to manipulate this on an iPad. No wonder my students are like, this is terrible. Actually, no, that'll work. I'll put a bracket there. I'll say plus 5 here. And then we're going to use a value of, they were using 30 in theirs? Okay. Not the most common value, but hey, take a look at this. So here's our answer, okay? And some things have changed. Like, it doesn't look, the axis of symmetry on a sine wave here runs right through the middle at y equals 0. It doesn't look like that. Like, this whole function has shifted upwards. It maybe shifted left and right, and it looks like it's stretched a little too. So it's hard to tell what points have been translated where, because this function just goes on forever and ever and ever, okay? So what we're going to do is going to build a small formula here, and we're going to call it x new, which is our new point, is equal to, actually, you know what? I lied. Let's define what our formula will look like. Y is equal to a, will be our first value, sine bracket, I'm going to say k, and I know you guys don't use k, but it's important to realize that it does actually exist. C, these are the key areas where you can put values, and we say plus d. Is that what the other one?
Yeah.
Okay, great. These are values that you can plug into an equation that will manipulate it. Essentially, A gives you vertical stretches and compressions, and D, so the two extremes, like the one farthest to the left and one farthest to the right, will give you translations vertically. So that's moving, I'm just going to say positive or negative. That's like moving the whole thing up or down. C does it horizontally. I'm going to say positive or negative. So it's going to move it left and right. And K does horizontal stretches and compressions. And I know you guys don't really use K, but essentially the idea is all your horizontal stuff is kind of in the brackets, and your vertical stuff, right there, this is all the vertical stuff. It's all outside the brackets, okay? So that's a way to kind of remember them. So if we're given an equation like this, we got to figure out, okay, where's the next point going to go? So we're going to build our own small equation so that you can translate every single point. So what I'll do is I'll just build another page real quick. What the heck? That's not what I want. Just go plus. That's what I wanted. So great. We've defined some of the things. So we've been given this equation. Y is equal to 2 sine x. Did we say plus 30? I think we did.
Plus 5.
Plus 5? Is that what we did? Oh, good memory on you. Great. So we need to define. Remember we said y is equal to a sine k x minus c and brackets plus d. So what we're going to do is looking from this kind of like a parent function here to the equation we have, we're going to define what's a, what's k, what's c, and what's d. Okay, so at first glance, do you think you know what a might be in this case?
2.
2, great. A is the value of 2. K is very tricky here because if you take a look, there is no value like outside this bracket here. It's assumed there is a value, and the value, if we don't see anything, is just the value of 1. Okay, so K is actually 1 in this case. Our C is that positive 30. Oh, I used green twice. No, I'm supposed to do yellow, and that means our D is the value of 5. Great. So now that we've done that, we can build some small equations. So I'm going to say your new x value is equal to your old x value divided by the value of k. And now this part's tricky. I'm going to say minus c, and we're going to talk about like what c is and what the actual value is. And your new y value is equal to whatever your a is times the old value of y plus the d value. Lots of letters, lots of colors. It can be a bit confusing, but we're going to do this one step at a time. The next thing we're going to do is we're just going to take, we've already defined what the letters are. Here's A, here's K, here's C, here's D. We're going to plug them in, and this will become a small algebraic equation that helps us go from like one table to another table, okay? So let's see what we get here. We get x, the new x value is equal to the old x value divided by K is just 1, and C is subtract, and that says positive 30, okay? So subtract, I'm going to write it like this, positive 30. So it's important to understand when there's like two integers or operations together what they're going to simplify into, so we'll talk about that. And y, the new y value is equal to the a value, which we said was 2, multiplied by your old y value plus 5. That one's a lot more straightforward. That's essentially the equation. I wrote k, but I think I said, did I say 1 out loud, or did I just...
Yeah.
Yeah? I don't always write what I say. Whoops, that's a highlighter. Yay, okay. We'll simplify this one on the left. The one on the right, the y equation, is as simplified as it goes. But xn, well, anything divided by 1,
1.
yeah, it's just the value that's on top. So 1 disappears. And negative and a positive together actually create a negative. So think of it like you're just going to subtract 30. Okay, so here are going to be our two equations. Now that highlighter comes in handy. That's no good. We'll do that and that. Those are going to be the two equations we use, okay? So, we'll shrink this just a little, so we don't need a whole new page. Remember we said those key points that are very important for our sign? We're going to call those x old and y old, okay? Because we're transforming from the first one, and we said it was 0, 0, 91, 180, 0, 270, -1, and 360, 0. Okay. Well, we need to transform into a whole new table of x new, so a new x value, and a new y value. So we take our very first one and we plug it into the formula here. So I'm going to do it on the top. We're not going to do all of them, but we're going to get the idea of it. So our new x value is equal to the old x value, which was 0. Okay, so I'm taking 0, and we're subtracting 30. Okay, so the new x value is -30. Great. So our very first point is -30. And now we're going to do the same thing with the y value and plug it into this equation. So our new y value is equal to 2 times 0 plus 5. Well, 2 times 0 is 0. 0 plus 5 is 5. So our new y value is 5. So our very first coordinate is very different. That 0, 0 is now at negative 35. Let's just double check on here. Can we get that? Negative 30. I can show you how I can find negative 30. I'm going to say x equals, I can put x equals negative 30, and we'll just see where it intersects. Helps me visually. Negative 30 and 5. Great, that's one of the points. We've discovered where it is. So it's a bit tedious, this way to do it, but you can just translate every single point doing the same thing. So we'll do the next one. 90 and 1, okay? So take 90 into this equation. So x new is equal to 90 minus 30, which is 60. Okay, so the next x value is 60. And 1, well, we take our y new is equal to 2 times 1. So we're taking that formula again. Plus 5. 2 times 1 is 2. Plus 5 is 7. So our new y is 7. There's the next one. Great. So 60 and 7 should be a coordinate. I'll do the same. I'm just going to move this to 60. Can I get that far? No, I can't. Let's see. 100. I'm just making a slider here. This really no bearing on what we're doing. 60. Come on. It's a Simpsons episode where your fingers are too big to... That's my problem here. Yeah, I got it. 60 and 7. Great. There's a major point, okay? And actually, you'll notice that is a maximum, right? Just like this point here was a maximum, when it got over here, it got translated to a maximum. In fact, we'll discover, we said x is equal to negative 30. That other point there, that's the axis of symmetry. That's the exact middle of this thing, right? So we start talking about like axis of symmetry, maximums. This is going to be your minimum point, which used to be at negative 271. Well, if you plug that into the two equations, you're going to end up there. So you're going to discover, excuse me, all 5 of those points will correlate, but it's been changed. You know, it's stretched vertically, it's got shifted to the left, it looks like, and it got vertically translated upwards also, okay? So you go through this formula enough, because I'm going to tell you, it's a bit tedious to do, but it's a great way to start. But you do this enough, and you'll start to get an intuition for like, okay, so I know everything's going to compress here and move this way. It'll make a lot more sense to you, okay? So let's give that a try.